Cool. So yeah, thanks very much. So this is my presentation on modularisation. So we at Kogan have done, over the last 6 months to a year, we've kind of shifted our architecture from a kind of big app to kind of splitting things up into smaller modules. So I'll talk through a bit of kind of what the problems we had with the original app, what we were trying to solve, an architecture diagram, which is always fun, and how that everything was going to fit together, and ways that we can manage risk. One thing that was really important when we were doing this change is that we can't have any downtime of the app, because any downtime costs money. So that's kind of was our main thing, is we've got to do this in a safe way. So at the end, we'll look back how this journey's gone. We're kind of 3/4 of the way through. We've not completed all the modules, so kind of our original plan, kind of where we finished off, has changed, and yeah, so we've improved things along the way and that sort of thing. So just an introduction to get things off. I'm originally from Scotland, so apologies if you struggle with my accent in advance. Hopefully you can still understand me. I've been an iOS developer for roughly the last 8 years, originally in Objective-C, so there was some of that from the keynote this morning, were some pain points definitely. And yeah, moving on, learning Swift, and then the last year or so we've started doing Swift UI. In the UK, I worked for a company that was an agency, and then now I work specifically for Kogan, where I'm the mobile tech lead. I moved to Melbourne in January 2023. When I'm not working, you can find me walking around South Bank with my dog. This is Smithy. That's his favourite stick. And yeah, so every time I go out, he's got to bring a stick home. So he was proud of this one. So if I'm not out walking with Smithy, I'm usually trying to work out how much beer I'm going to get when I'm ordering in a pub, because I still can't understand in this country. So in order to give you a bit of context on who is Kogan.com, it will become clear why we've got. So for those of you who don't know who Kogan.com are, it's one of Australia's largest online-only retailers, focused on bringing the most in-demand products and delivering them at affordable prices. The company began in 2006 in Russell & Kogan's garage, who's our CEO and founder, initially selling televisions before expanding into many categories. It's grown into the largest online-only retailer, and then some of the impressive stats you can see on the screen here. So over the years, Kogan.com has acquired multiple businesses, which include Dick Smith, Matt Black, Rosa, and it's got a footprint across Australia and New Zealand. So the way the website works is for each of these different brands, they all run off the same code base. So we've got a platform that runs all these different brands. They're just styled differently. The back-end services are all the same. So what we want to do with our mobile apps is have the same thing. We basically want to have an app that is essentially a white label app that we can say it'll work the same. It's just going to be styled and branded differently depending on how we want to do that. So that's where modularisation comes in, and that's why we have decided to go with this approach. So yeah, as you can see from these images, these are 3 of the websites we've got. So we've got Kogan at the top, Dick Smith, and then Matt Black at the bottom. They look very similar, just kind of different styling, just some different colouring and things. But yeah, they function the same code underneath funds them. It's just different styling on the top. So before we get started, it's good to look back and kind of, there was a lot of problems in the initial state of the app. It was written about 5 or 6 years ago, and over the time there's been multiple developers working on it. There's been kind of, people come in for 6 months, leave, and then kind of all these different ideas have added to it that have, just left a mess, to put it nicely. One of the main problems that we had was the app was very inflexible. So one of the examples that I always like to use is that on our home screen, we've got a row of kind of products that we display. We had a request to market, and they wanted to add an additional one in. It was an urgent request and was going to add value to the business. But the only way for us to do that change was to go through the app release process. There was no way for us to just update that. So that's, for me as a developer, that kind of scares me. Everything in an app should be flexible. I've had that kind of drilled into me from a very early age, that your app development, you've got to be flexible. So there was a lot of hard-coded strings as well. Not doing this. So there's a lot of hard-coded strings adding to the inflexible problem. This meant that any time we wanted to change even like a simple bit of text, we want to change the button from hello to hello 2, then we'd have to make a release to the App Store, which is just not feasible. It's kind of, you know, everyone knows the problems with releasing, the time it takes and all that sort of stuff, so it just wasn't working. Over the years, there's been kind of multiple developers working on it. They all would have kind of different ideas of how the architecture should look and how the architecture should work. So there was a lot of different kind of architectures that had been attempted to, and it was kind of like, there was a conflict between each other, and they're really difficult to manage and update. So there was an attempt at MVVM using RX Swift. There was another attempt at the coordinator pattern, which actually ended up causing quite a few memory leaks in the app because it wasn't done well. So yeah. There was also a lot of UI logic was ingrained into the code in any nib files, which is a major problem for what we're trying to achieve with being able to change the UI and the styling on the fly. So that means that there was a change we wanted to make where we wanted to change the font throughout the app, which should be an easy thing. You just change that initial font file and it pulls through. But the way the font had been done, it wasn't possible to do that because we had to change it in all these different places. And it ended up taking a very manual and kind of, it took way too long to do. We didn't like that. There was also a lot of similar components, kind of touching on the reuse stuff from Sam's talk earlier. We had a lot of kind of components that started out being very similar, and then over time they had diverged. So an example was on the home screen of the PLP, the product listing page, and the PDP, the product display page, there was a cell for a product. This cell looked kind of exactly the same, but it was written 3 different times. And so every time we wanted to make a slight change to one of these, we had to make that change 3 times. And yeah, there was inconsistencies between them. Not a good situation to be in. Yeah, it just multiplied any effort that we had to do with anything that we were trying to achieve. There was also a lack of any unit test coverage, so the code was written in a way that wasn't very testable, so it was very difficult to add unit tests to existing code. And then, yeah, finally, it was all written in UIKit. So Swift UI was released in iOS 13. It was only really, from my perspective, kind of production ready from about iOS 15 onwards is when I kind of would suggest that's kind of, for me, I'm happy to have a Swift UI in an app from iOS 15 onwards. So our app was completely UIKit, and we wanted to migrate our app to Swift UI to enjoy the various benefits of it, and the decorative syntax, making it easier to read, write, and understand. And then the live preview feature, which doesn't actually work that great, but it allows us to make changes in real time, which is really cool. So, despite all the problems, I like a challenge. So rather than running away and trying to maintain a difficult and out-of-date app, I decided to find a solution to fix all these problems. Modularisation. So what is the solution? At Kogan.com, we decided the best plan of action was to split our app into modules, each with an individual concern that is in charge of. I'll start by running through some of the benefits of switching to this approach, some of the disadvantages, walking through the dependency layer, which is the key link between the app and each of the modules, an architecture diagram, and then going into some of the modules in more detail. Okay, so what are some of the benefits to switching to a modular approach? So the better separation of concern, so make things easier to maintain and reduces complexity. Improve textability. The idea of what we were aiming for modularization, which didn't end up working out, is that each module itself would have its own Git repository. So we'd have the main app, and then each kind of separate module would have its own Git repository, that would have its own tests. It would all run, all have tests, and kind of all be great. That didn't end up working out. That was our original plan, but that was the idea. We do still have in our apps now that all our view models are fully unit tested, which is a huge step forward from where we were previously. But we decided not to do the separate Git modules, which I'll get onto later on. Faster build times. So because we have these split up into different modules, kind of everything's down into smaller chunks, it's already been compiled. So those in turn gives you faster build times. And then you've got faster build time. That just internally means we've got a faster CI. So we can build quicker, we can release things quicker, and it's just a smoother development process. Smoother development, so developers can work on different parts of the app. So for example, if they want to work on the home screen, they can work on that and not have to worry about making a breaking change on somewhere else in the app. It's really they don't need to worry about conflicts or anything like that. I'm sure all of you've had project file conflicts and those sort of things when you're trying to do working in a team. So yeah, it's really good to just separate that. We can just focus on development rather than worrying about conflicting with one another. One thing that's specific to this design, so I've put it is a benefit here, but it's not really about modularization, is app themes. So app themes is very powerful and gives us a lot of flexibility to change the designs of the app. So that is how we want to be able to do things with our modularization approach. So yeah, there are obviously some disadvantage. It will be a large initial development effort, doing the switching to a whole modular architecture will involve a large amount of development time and effort. But I think the benefits that we get from it are worth the effort that it's going to take. If we have any shared modules, they can be difficult. So you'll see in my architecture diagram, we just have the one core module. The reason for that is that any changes you make to the core, they need to feed through to all your different modules. If you've got a multiple of those, that becomes a problem because you've got to go change it in all these places, and it just becomes too difficult to manage. And yeah, finally, the risk of breaking changes. So because we were writing complete different sections of the app, so we'd rewrite the home screen, we'd rewrite the cart, that's a whole it's a risky thing to be doing. So we need to make sure that we don't break any of the existing functionality. And I'll talk a bit more later about how we attempted to risk management this process. So the architecture diagram. So this is basically where we decided to get to. The modules here that you see are mostly match up to our tab bar in the app. We've got a networking module, which is does all the networking calls. We've got home, which is the home screen. Search and browse, it's like search pages, browse tab. I'll leave orders for just now. Checkout is cart and checkout tab, and the account screen is just all the account management. So the reason why we decided to split orders out is it was complex enough to need its own module. It could have been in the account modules if it was going to be to that tab bar design. But we decided to split it out because it was just quite complex logic, and so it made sense to split it out. So one thing we wanted to do in this architecture was to ensure that we didn't have multiple layers. Each layer of the modules adds in extra complexity, which can quickly make the app become unmanageable. So you'll see here, we've just got Kencore, which is we reuse to everywhere. So that's got our UI models, any reusable components, that sort of thing. I'll go into more detail about the modules in a second. So one of my previous experience I had with a team who had tried modularization. They had it so each of these modules had a core and a UI layer, and it was so difficult to work. So on paper it looked like it should work. In practice it really was a mess. So the management of trying to overhead to manage all these changes, doing multiple merges to merge this into here, version updates, all that other stuff, that was made things so much more difficult than it had to be. And so that's why we've really stuck to just that Kencore as the only shared module. So the key link between all of these modules is the dependency layer. It acts as the main link between the main app and its modules. The modules will use the dependency layer to access anything contained within the app. So the main app still remains the boss that's in charge of managing user state, anything like that. The modules are dumb in that respect. They just go to the main app and say, give me my logged in status, give me my user details, give me what color this button should be. They really are just the display and that. The app is still in charge. We use protocols quite heavily to define the required methods. That really helps with testability, so we can define a protocol how this class should be, and then we can mock a whole dependency layer, and that allows us to mock data right the way through the modules and really helps with our testing. And yeah, Firebase remote config. So one of the problems we had before was kind of not being able to update any strings in the app. So I'm hoping a lot of you would have heard what Firebase remote config is, but it's basically a kind of, we use it for string management and kind of string management, JSON, that sort of thing. It allows us to remotely update things on the fly. Really great, and a really great free tool that Google provides. So yeah, we use that, and we access that through the dependency layer. So the main app is still in control of each of those strings, so we can have different remote config values for each of our different apps. We also have networkings controlled by the main app, so you'll see in this architecture diagram that, for example, if I want to make a call from this account screen, it would go to the dependency layer and then go up to the networking layer and come back, and kind of that's the link between these two. So the account, the checker, order, search, and browse and home will do no networking itself. It will all be controlled by that networking layer, controlled through this dependency layer. So styling is essential for us. So with our dependency layer, we define the colors, fonts, and assets, which can be used by each modules. So we can style the module differently depending on which brand we are building. And it also ensures a consistent behavior with different styling. So Kencore. The Kencore is the main module, which is common to all other modules. So we worked with the design team to compile a list of required reusable components, which will be housed within the Kencore modules. And these can then be used throughout all our other modules. The reason why we did it with the design team is to make sure that these were the ones that the designers were going to use. We didn't want to kind of create these reusable components and then the design team come to us and say, oh, can you change this? Can you do this? We want it just to be, here's what we can use in our apps, we can use it anywhere. And that was a really consistent set of those components. And it has worked really well. An example of a reusable component would be a text field, which can be used throughout the app and designed for the various different error scenarios. So if you've got a text field, we've had each of the different kind of places, kind of here's your error, here's kind of how it's an error, how it's an empty state, placeholder state, those sort of things. And then, yeah, that looks the same for all our modules. UI styling components. Yeah, so it's also got the API models, any mock data that's used throughout all the modules. So the reason why we decided to put the API models in here rather than networking is that it has to be used throughout all the modules. So the whole model needs to know about what API models it's using. So that's why it's not in the networking module itself. We didn't want to create that kind of double dependency layer there that kind of networking needs to be added to all different modules. So that's why Kencore is where that is housed. And it's also got kind of some handy extension, kind of Swift UI modifiers, that sort of thing that kind of just good to use through our apps. Yeah, so styling fonts. So as I kind of touched upon, this is how we use our protocols to style our app. So for each of our brands that we've got, we will have a style guide that will conform to this. So if you've used material design, this will probably look familiar to you because this was kind of done in conjunction with the Android team as well. This allows us to kind of have different fonts for each of the different brands. We can kind of say for call out, we can change that font, and that'll just pull through to all our modules where we don't care, as the module doesn't care what font it is, it just gives me this font. Doing it this way also enforces us to use the style guide. So as a rule, we will not use any font or any color that is not in our style guide system. So we kind of will push back to the design team and say, no, we can't use that because it's not in here. And that's a rule that they're happy with, they agree with. So it's worked really well. There was kind of the old kind of styling thing did have this, but also had about 30 different things at the bottom of edge cases of kind of a different font size and kind of that, which doesn't work. So yeah, that's why we're really forcing with this style guide. We've also got a similar thing for colors. So again, kind of the material design kind of colors that we've used. Cool. Okay. Previously, our implementation was all hard-coded and kind of stored in the apps code. We had no flexibility to change without making the apps a release. We also had issue that older app builds would still potentially be using outdated networking implementations. So when you release an app, what's out there is out there. You can't change what's out there. So what we want to be able to do is have everything in remote config. So we have basically a JSON file that controls, and we can configure everything. So we can change the URL path, if I can speak, any HTTP headers, post data, and even whether or not to cache the response, and then all driven by remote config. And so what that does, it allows us to easily change our networking calls for our different apps. So if, for example, we need to add an additional post parameter for Dicksmith, we can send that easily without having to do any complex logic that's housed in the app. That's all driven by the remote config and kind of drives to the app. Yes. So as I previously mentioned, anytime we wanted to make a change on the home screen, we had to do a release. We also had a challenge of supporting older app versions again here. So potentially users were not seeing the most up-to-date home screen that we wanted to, because we just couldn't update this. So we had, if people are on the older version of the app, they're not going to see our latest kind of changes that we've made. With our move to the modular architecture, we've now used remote config, which allows us to make this all configurable. So this home screen is completely driven by a JSON file that's stored in remote config, and it'll basically say where to go get that data from, and it'll go make the network calls for each kind of section. So we can update the sections, we can add, remove any of the modules without needing release. And this also provides a solution to our problem for the older app versions. We can make changes to apps that are already out and already on people's phones, and we can get changes to them faster without them having to update. The account module was in a similar state. It was really just hard-coded. We wanted to be able to control the account screen without having to release. So we did pretty much the exact same thing. Deep links. So at Kogan, we use a lot of deep links from emails, kind of marketing emails that say, here's a product, we want to get into that product and buy that when you click on it. So the ability to handle deep links within our app is key. Before we began, our app contained a disgustingly big if statement handled in the front end, which would work out from the URL that we're given where it should lead to. So the Android app had a similar if statement. However, over the years, the two had diverged and ended up with different behaviors between the apps and really not a great user experience. So we were constantly getting issues raised by our kind of marketing team, different teams in the business saying, why is this not working? Why is it working here but not working here? And it was a real problem for us. So as an app developer, I do everything in my power to avoid having any front-end logic. So if there are any problems with the logic you add on the front end, your only option is to release an app, challenging, time-consuming, and result in app users using inconsistent logic implementations. So in order to solve that, we created a back-end deep link service. So the way it now works is that whenever a user will click on an email, it gets passed to our app. We'll then send that directly up to our backend. The backend will do that logic and tell us where that needs to go. And it's returned to navigate. Where we want to navigate is returned to the app. So one of the main benefits for that is there's now a centralized place for that logic. Therefore, iOS and Android will handle that deep link in the same way. It provides a consistent customer experience across both platforms. The other benefit is, of course, not having to release an app store to change every time we want to change any logic. We again use protocol heavy within this implementation. For example, we can take the user to one screen within the app for Kogan and a completely different screen for Dicksmith. Cool, so managing risk. This is obviously really important. In order to reduce the risk of causing break-in changes, we use feature flags to slow release code to our users. Any e-commerce app, anything broken could have severe consequences. So it's vital that our users are still able to check out and make purchases. So that means we can easily kind of turn things on, turn things off without causing issues. If there were any issues, we can roll it back. In order to test things in our UAT app, we use our settings page. So here you'll see kind of we've got things for the different modules, so we can turn them on and see that they're working. We can make sure that things are working, so we can kind of, does the new home conflict with the new car, for example? We can test it in the test environment and make sure the settings are correct, and you can test the individual components. Maestro. So I don't know if a lot of you have heard Maestro, but Maestro is a UI testing framework that we found during our implementation. So it's basically a test that you write once, and it runs on both iOS and Android, and it's been very impressive. So it has built-in tolerance for any flakiness or any delays, which makes it more reliable than any other of the UI testing frameworks I've used, and that includes kind of Apple's own kind of XE UI tests. We began writing for our features, focusing first on the checkout. So because we weren't redesigning everything, what we could do was write our tests against our old implementation and then run them again against our new implementation and ensure that they then worked. So that was really key for us to make sure that things continued working as when we switched over to our new implementation. We also have web view fallbacks. So at Kogan.com, we've embraced the hybrid approach. Any downtime of the app costs us money. We're a much smaller team in comparison to the larger web team. So we've found at times that we're struggling to make any improvements to the app because we're just constantly trying to keep up with kind of what the web team are trying to do. We want to develop mobile first features, but because we're continually having to keep up with those changes, we weren't able to make the changes that we wanted to. And so that's why we've started to use more web content in our app. So as an app team, we want to, so we chose the account screen to test this out because it's vital that the user can be able to do these functions. So they've got to be able to change their password, they've got to be able to change their name, change their address. But if they're not the best user experience, it's not the end of the world. It's not going to cost a customer. It just needs to work. So what we want to ensure, and you'll see in this kind of example here, we want to make sure that any headers or footers are hidden, so the user can't navigate away from what they're trying to do. So within this web content here, we don't want them to be able to go to the home screen and kind of be in a web app experience. And then we also want to, if you click on a link that has a native equivalent, we want to link directly into our deep link service logic for this. And then any analytics sent from the app. Cool, so what went well? We're now over halfway through. We're kind of probably more 3/4 way through now. We've had a lot of successes along the way. So we had reusable components. So we did work with the design team, and this has worked really well. And this has really sped up development as we've been going through. Despite the initial effort involved, it has proven to be a good thing that we've done. We've increased testing coverage, so we've now got 100% unit test coverage of all view models, meaning all business logic in the app is tested. And this testing ensures that we can move forward with confidence, knowing that any changes made are reliable. Flexibility, you probably noticed I've mentioned that quite a lot throughout this talk. It's all text in the module, it's all drive-through remote config, so we can change anything without needing that release. And yeah, so the white label app, we can style our modules differently, exactly what we intended to achieve. And also speeding up development. So as we go, we as a team have started to learn Swift UI, we've started to develop things faster. With our set of reusable components, the output from the team has increased. We've really built a strong foundation to build on, and we can utilize this going forward. And yeah, so it's not all been great. There has been some problems. So as we completed modules, we would go through each different part and do a review and say kind of what can be improved. So we're always iterating, always trying to improve. So on paper, the idea of splitting things up into separate Git repository made sense. It allowed for better separation of concern, and we could create an example app for developing in isolation. However, in practice, this didn't work, and it resulted in a lot of overhead in trying to keep things in sync and modules up to date. And we also found that when we were UATing, there was problems that were working in that example app, that when we pulled them into the main app, they didn't work in the main app because there was some kind of difference there. So we reflected and decided that the best approach wasn't to import the modules directly. It was to remove the Git repositories, and it's all contained within that main app. So we've got just one app, and it's kind of really reduced the complexity of the modularization. But still, we've still got those different Swift packages, so they are still separate. We can still make sure we've still got the benefits of modularization without the overheads. And then finally, we've got some front-end business logic. So there is still too much in there. It's all tested now, but there is still too much business logic in our apps. Yes. So thank you very much.